This video is all about proving the derivative of sine and cosine function. So we are trying to show how these are derived, how they come about, the derivative of sine x with respect to x equal to cos x, and the derivative of cos x with respect to x equal to minus sine x. So, but before we start, I want to use this medium to appreciate my subscribers and new subscribers. I also do well to also ask my viewers. I also appreciate my viewers and also use this medium to please ask them to subscribe, like, make comments, and also share this video. So let's begin. Now, we want to prove the derivative of the x the sine x with respect to x as equal to cos x. So for us to make this proof, what I will do, I will say let this, if you have something like this, d sine x all over the x. Now we'll now say let y equal to sine x. So that means we are looking for derivative of y with respect to x, knowing fully well y is equal to the function of x, which is equal to sine x. So now let's begin our derivative. Having assumed that our y is equal to sine x. Now, if you have, let's say you have an infinitesimal y added to this y, you will now have the sine function of x plus a little change in dx. So that is what you're going to have. So now, having gotten this, we know the value of our y. Let's say this is equation 1 and this is our equation 2. Now if you move this y to this other side, you have delta y equal to sine x plus delta x minus y. Now substituting the value of y equal to sine x into this equation, let me call this equation 3, into equation 3, you will now have sine x plus delta x minus sine x. Now from here, applying this rule where you have applying the product rule, sorry, the addition rule. Okay, let me say applying the product rule. The product rule, when you have sine a plus b minus sine a minus b is equal to, this value is equal to cos 2 cos a sine b. So this expression is 2 cos a sine b. Now, if you want to know how this is being proved, there is a link below. There is a link in this video that I showed how this came about. If you want to know how we got this expression, which is the product rule, that is the trigonometric product rule. So you go to that section and now be able to, so that I will save more of the time You can go there, look at it, and you can come back and continue with this video. So now let's continue. Now you have, since we have this, that means from this expression here is minus. From this expression, that means a plus b is equal to x plus change in x, while a minus b is equal to x. So this is equal to this is equal to this. Comparing this to be this. Now if we add, let's call this equation 4 and this equation, okay, let me call this equation 5 and this equation 6, since this one should be equation 4. Okay, this is 4, sorry. This should be 5, then this is 6, this is 7. So now adding equation 6 and 7 together, you have a plus a, which is 2a, b minus b will give you 0. Then a plus a will give you 2x, sorry, x plus x will give you 2x plus change in x. Now dividing both sides by 2, you have this 2 cancel this 2. You have a is equal to x plus delta x all over 2, which is equation 8. Now for equation, now let's write this again so that you follow along on this page. Now if we want to get our b, if we minus equation, what is it, equation 7 from equation 6, you have, if you put minus here, a minus a will give you 0. Then b, if you put minus, minus times minus is plus, so b, okay, let me just do it. Say a plus b minus, this is minus, a minus b is equal to a plus change in x minus x. So if you open up that bracket, you have minus a, minus times minus is plus b. You have x plus delta x minus x. Now bring the like terms, you have a minus a. This is plus b, which is x plus change in x minus x. This x will cancel out this x. So now this a will cancel out the a. You have 2b is equal to change in x, so delta x. So if you divide all through by 2, these 2 will cancel out this. You have isolated b, which is delta x all over 2. Now using this value here, now you see, using this product rule where you have sine a plus b minus sine a minus b is equal to 2 cos a sine b. So applying this rule, that means our change in y, which is equal to sine x plus change in x minus sine x. Now applying this rule, then sine x plus delta x minus sine x will be 2 cos, our a is what? Our a is x plus delta x divided by 2. So x plus delta x divided by 2 sine dx all over 2, which is b here. So b is this, while a is this. So that is it. So applying this rule, this expression here in this form, so this is equal to this. So now we now have change in y. So now if you divide all through by infinitesimal change in y, you have change in x, you have change in y all over change in x, which is delta y all over delta x, is equal to 2 cos x plus change in x all over 2 sine change in x all over 2 all divided by change in x. Now we have this to be 2 all over change in x cos x plus dx all over 2 sine dx all over 2. That's delta x all over 2. Or dx delta x. Now, since we have gotten this is like multiplication now. Now, so this is like multiplication, just like you're multiplying this with this. Now, this whole thing is the same thing as saying 1 all over dx all over 2 times cos x plus delta x all over 2 sine delta x all over 2 all divided by 1 is the same thing. Now let's show that it's the same thing. If you have 2 all over change in x, this is the same thing as saying, now this whole thing is just the same thing as saying, now you are dividing, let me say for instance, I have, it's just like saying you have a, and a is the same thing as saying 1 all over 1 all over a. The same thing. A is the same thing as 1 all over 1 all over a. In the sense that if you, just like a times 1, or say 1 times a, now if you want to say divide means you take the inverse of this. Just like you take the inverse of this, that becomes 1 over a. So this thing now means 1 all over 1 all over a. So that is it. Just like as this thing is now, you now have 1 times 2 all over change in x. Now if you want to change this division sign, it's just say division sign, you inverse this, so it will now be 1 divided by change in x all over 2. So that is how I change this to be this form. So that is it. So now let's apply that. Let's apply this expression now. So we now have changing, sorry, this is supposed to change in y. Let's say delta y. Let me use one particular terminology. Delta y all over delta x is equal to cos x plus delta x all over 2 sine delta x all over 2 all divided by delta x all over 2. So it now boils down to this, because this expression, which is delta x all over 2 times 1, will give you this, while 1 times this whole expression here will give you this. So that is what we come to. Now, you know, the y all over the x according to the law of the derivative, is equal to the limit when delta x tends to 0 of delta y all over delta x, which is equal to the limit of delta x equal tending to 0 of this expression, which is cos x plus delta x all over 2 times sine delta x all over 2 divided by delta x all over 2. So this expression, let me now use dy all over dx is now equals to the limit of delta x tending to 0 cos x plus delta x all over 2 sine delta x all over 2 all divided by delta x all over 2. So this is the same thing as saying the limit for delta x tend to 0 cos x plus delta x all over 2 all over 2. Let me make some correction here. This is supposed to be only on this, and then times the limit of delta x tending to 0 sine delta x all over 2 divided by delta x all over 2. Now the whole of this. Now for this expression, let me say delta y dy all over dx will now be this limit now for delta x tending to 0, the limit of this function when delta x tends to 0, if you just put, let's say you substitute delta x equal to 0 into this equation, this whole place will be 0. Then here you have x, or you put an infinitesimal value of delta x. That means this value here is negligible. Dividing by 2 is negligible. So you have x. So that this limit here now will just tend to cos x times the limit of delta x tending to 0. Here you have sine delta x all over 2 all divided by delta x all over 2. This expression, this limit is equal to 1. But let's prove how is equal to 1. Now, the way to prove it, let's use what we call the power series. The power series of sine function. Now we have sine x sine delta x all over 2. This is the same thing as saying this is just like the sine function of this, just using the sine function where you have summation of x, a summation to infinity n equal to 0 minus 1 raised to power n times, now you say times, here now you have x raised to power 2n plus 1 divided by 2n plus 1 factorial. Now since it's the x over 2, sorry, so here will be delta x all over 2 all over 2 all square. So that is what you have. Now if we imputing n equal to 0 here, you have this as our n equal to 0 here too. So we have delta x all over 2. Now divide by 1 factorial. So now if you put 1 here, you have minus 1 times, if you put 1 here, you have, if you put 1 here, now you have delta x all over 2 to the power 3. If you put 1 here is 3 factorial. Now, if you take 3 here, if you take 2, sorry, the next one is 2. 2 here becomes plus. You put 2 here, you have delta x all over 2 to the power 5 divided by 5 factorial. So plus, you continue. Now, if you now divide, let's say we are dividing this whole thing by the x all over 2. The same thing. So this whole place will be divided by the x all over 2. Now, if you divide this whole thing by the x all over 2, this value, now you will now have this expression, you now have this sign change in x all over 2 divided by, sorry, delta x all over 2, sine delta x all over 2 divided by delta x all over 2 will now be equal to, using this, you now have delta x all over 2 divided by delta x all over 2 minus this expression. So minus this expression, this will now be delta x all over 2 to the power 3 divided by 3 factorial divided by delta x all over 2, then plus delta x all over 2 to the power 5 divided by 5 factorial divided by delta x all over 2. So plus, so continue. So now this place will give us 1 minus this will give us delta x all over 2 to the power 2 all over 3 factorial plus delta x all over 2 to the power 4 all over 5 factorial plus. Now, we now have this all over delta x all over 2. So the limit of sine delta x all over 2 all divided by delta x all over 2 when the x tends to 0 will now be, here will be 1. If you put 0 here, the whole of this will be now be 0 plus 0 minus 0 to infinity. So the whole thing is 1. So that means the limit of sine of the x all over 2, sine of the x all over 2 divided by the x all over 2 when the x tends to 0 is equal to 1. So it has been proved. So now that means if you put that, if you put 1 here, that means the y all over the x is equal to cos x limit of sine delta x all over 2 divided by delta x all over 2 when the x tends to 0. So this is equal to cos x because this one is 1. So 1 times cos x is this. So that means you have dy all over dx equal to cos x. So where y is equal to sine x, so you now have d sine x all over dx, where with respect to x is equal to what? Cos x. So we have proved this. Now let's work on the other one. You have delta cos x all over dx is equal to minus sine x. Now let's assume that, let's use t is equal to cos x. So t plus delta t is equal to cos x plus delta x. Now if you move this t to this other side, you have delta t is equal to cos x plus delta x minus cos x, which is, let's say, minus t. And you know that from equation 1, this is equation 2. Now from equation 1, t is equal to cos x. So substitute it here. You have delta t is equal to cos x plus delta x minus cos x. Now if you divide all through by delta x, you have, now but before we do the division, let's apply product rule. The product rule states if you have cos a plus b minus cos a minus b is equal to minus sine a sine b minus 2 sine a sine b. So this trigonometric product rule has been proven. So if you care to know the proof, please check the video. There is a link below this video. Check that link, you will see the proof. That is the product rule proof. Let me write it. Product formula. This is a trigonometric, it's a trigonometric product formula. So you look at it, it's just the same thing here too, but that one is cosine. It's just the same thing here. This is also a trig product formula, not rule. So there is also a link in that one, in that video. You in a single video you have this proof. This one and this one is proved in that video. So now, having gotten this, now let's assume that a plus b is equal to x plus change in x, and a minus b is equal to x. Now meaning that here is change in x is equal to a plus b, here is x is equal to a minus b. So which is, we can call this, let's call this equation, what was the last equation? The last was 8. Let's call this equation 9, equation 10. So if you add them together, adding equation 9 and 10, you have 2a, a plus a, then b plus b minus b will give you 0. So a plus a is 2x plus change in x. So if you divide all through by 2, you have these two cancel out. You have a is equal to, here will be, here these two cancel out. You have x plus delta x all over 2. So this is equation 11. Now if we subtract equation 10 from equation 9, you have 2b is equal to delta x. So if you divide these two, if you divide them by 2, you have b to be equal to delta x all over 2. This is equation 12. Now let's now impute all this. So now we replace a plus b with this, a minus b with this, then a with this value, b with this value in this equation. So now since you have we now have the x plus changing delta x minus cos x is now equal to 2 minus 2 sine x plus delta x over 2, sine delta x all over 2. So there is a minus here. So we also make this. So now there's a minus. So now this is sine. Now let's call this equation 13. Now substituting equation 13 into this equation, into here, you now have delta t is equal to, delta t is equal to cos x plus delta x minus cos x. So where we see this, if we replace it with this, so we will now have minus 2 sine x plus delta x all over 2, then sine delta x all over 2. Now you have this delta t. So dividing all through with delta x, sorry, you have delta x. So the t all over delta x, delta t all over delta x is same thing as this. So this is same thing as minus 2 all over delta x sine x plus delta x all over 2 sine delta x all over 2. Now we know that dt all over dx is equal to the limit of delta x tending to 0 delta t all over delta x is equal to the limit of delta x tending to 0. Let me put the minus, this minus here, then 2 all over delta x times sine cos times sine x plus delta x all over 2 sine delta x all over 2. Now we now have, okay, let's can't enter that space. Now we now have dt all over dx equal to minus the limit of dx tending to 0 sine x plus delta x all over 2 times the limit of sine delta x all over 2 tending to x tending to, okay, no, before I do that, let's work this out. Let's work, okay, let me still continue it that way, times 2 all over delta x Now we have minus. Now from here, 2 divided by dx is the same thing as saying 1 times 2 all over dx. Now if you say 1 divide, you reverse this, so now you have dx all over 2. So this is the same thing as 1 all over dx all over 2. So that is it. So now we'll now have minus limit dx tending to 0 sine x plus delta x all over 2 times the limit of delta x tending to 0 sine delta x all over 2 times, this is same thing as this, times 1 all over delta x all over 2. So let me demarcate this. So that means since delta x tends to 0, if you put 0 here, this one will now be minus sine x. Now this is still times the limit of delta x tending to 0 sine delta x all over 2 all divided by delta x all over 2. Now this expression here is equal to 1. So we proved it here. So there is no need proving it again. We proved that expression. We proved it here that this is equal to 1. So there is no need repeating it again. So you now have minus sine x times 1, which is minus sine x times 1 times minus sine x. So you have delta t all over delta x. So since t is equal to cos x, now substituting this cos x in place of t into this equation, we have delta cos x all over dx is equal to minus sine x. Let me write it well here. You now have d cos x all over dx is equal to minus sine x. So this formula is proved now. So it is proved. So thank you. So have a nice day. Please subscribe, like, comment, and also share the video. Your subscription is the fuel that helps me continue in these YouTube videos. Please try to subscribe. Thank you. When you subscribe, hit the notification bell